Someone asked me to give them a half an hour max video to tell them how everything failed. Simply, again, there's part of the reports show that it had deflection in the deck. The deflection in the deck resulted in all your cracks from there forward. The deflection in the deck was not addressed. That's what's going on here. But the NTSB, being that they were lobbied, is trying to elude, stay away from that. The deflection is the issue. That means the span can't hold itself. And they're just trying to go into one further point down into the collapse, which would be the progressive collapse, which would be the something they're working on down here. Look up the word post hoc. Post hoc means just because one thing happened doesn't mean it caused a failure. It's not the related failure. This is a deflection issue in the deck. NTSB would have you believe that in all the reports that it pushed through, the 12 pushed through. Let me see if that 11 pushed through 12 and because they were post-tensioning and caused all this failure. That they did the post-tensioning over there while it was still in form work, and no failure represented itself. They tell you once it's detension, now all of a sudden we talk about, how how putting tension on here caused a failure, but they're just jumping to a further down mistake. It's something that happened before that. As Denny Page stated, hey, it was standing up over there before, but they don't address the shims over there, that how it was shimmed. I have not found it yet. How it was not shimmed underneath this diaphragm here, as compared to when it was sitting over there for a couple of weeks without supports. But again, the deflection was mentioned, and that's the beginning of the failure. They had cameras out there, photographs, the NTSB. We saw the NTSB out there with tons of cameras, right? They have all those photographs. I've asked the NTSB for them, and now I've got to ask again, I guess. But they are not presenting any photographs of all those cameras out there. Those reports have those photographs of all those workers. Their field notes have those photographs. I want to see those photographs. I don't want to see this made-up scenario using computer-generated programs and fakery, because they've been lobbied. Again, NTSB's been lobbied by Figg. I did a video on that, and literally what, 100 and I don't know, 200, I don't know what they're, $100,000+, $120,000+ already. So they got what they paid for. They're trying to push us off towards MCM, VSL, quite a few things besides addressing the real data, the deflection that was already happening beforehand. So NTSB, they're terrible that way. They do part of the federal highways documentation here is they talk about this shearing off, but then they remove, again, just like everyone else, they remove the lower post-tension bars, number 11, and the upper post-tension bar, number 11, from their sliding action not being in the way. As we can see here, this is just piano key down, zippered on down, right down these stirrups. It did this as the deck fell down. It ripped it down. If it was to slide, causing this sliding action, it would have to go through this at that point, up there, not down here. They don't show any evidence that took place. They actually removed the post-tension bars, number 11, upper and lower. They call those north and south in the reports, I've noticed. So this would be north, and south would be the deck, the lower one. They remove them. I find that quite nefarious in its actions. This right here, I've been holding out, looking to see if any other forums would do it. I'm going to show a photograph where it's going to show that the upper, the north end, and the concrete between these two broke internally, which is interesting. Just an interesting point that wasn't addressed. All the photographs of those guys out there, we no longer have access to them. I mean, we don't have any. They're not presenting the photographs. They're presenting a drawing and saying this is what it looks like. Yet they had hundreds, I'm guessing thousands of photographs with the NTSB. They could have said, here's the photograph of what we're talking about. But they instead resort to drawings. Let me jump out of here and get to something else. The Federal Highway document will talk about this crack right here by putting red arrows on it and in the caption below, they'll say the cracks at the deck. Clearly, this is not in the deck. They talk about this number 11 being able to push off 12. And again, we see these are open. They know what an open crack represents. That it's a tension in there and it's open. It's not compressive. This clearly represents a twist, a torsion, a rotation, and yet they're not addressing it. They talk about it in a couple of points by saying, I did in a previous video where another part of a report will talk about showing the drawing before it moved without the post-tensioning members in it, how this bridge is out of equilibrium. It has a torque action in it, a twist in it. If it has a torque and twist action in it, how did post-tensioning all of the longitudinal cables of equal post-tensioning take the torque out, the twisting action? If they're all equal, you did nothing but put the post-tensioning equally in there, so the torque action, twisting action, rotation action, however you like to look at it, still exists. It still exists. So this bridge is not in equilibrium. It has a torque twist action built into it. It has a deflection built into it, which I'm going to show you in a minute also. But again, this is my number one photograph showing the twist torque action after detensioning. What's going on here? Let's right close clockwise. So this is the one that they refuse to address this. The reports all, this is the number one thing, my takeaway for this, and I got to keep this under half an hour for my man that asked me to, so I'm going to see if I can do that. My number one takeaway is they're saying this broken arm, a broken leg, can push off number 12 off of the deck. It has no ability to do it. They don't talk about none of the reports so far I've found talk about the strength in this number 11. None of them, they all state it's permanently okay. None of them state that they don't do a detraction or a deduction. Sorry, my voice, guys. I'm really hurting here, my throat. They don't do a deduction for this thing totally being twisted, torque, split up. They just count it as A-okay. It's 100% okay, and the compression just made this broken leg kick number 12 off the deck. This broken leg has open wounds. It's bleeding, if you will. I'm just trying to talk to you about it. It's open. It's an open fracture. It's not closed. It's not compressive. It's got a twist here, and you could say that the twist here, it's open here. You could say on the other side it might be compressive on the other side. On this side it would be tension side as it rotates, twist. And there's your opening. This thing is torqued all hell. Let me get you the data. So I Google search FIU bridge collapse NTSB, and I get these images. We see the J bars, etc. Now, interesting enough, we don't see them walking around with all those cameras anymore. This is the deflection I'm talking about. The deck was. I'm going to show the deflection comment where they address it. Figg says, well, it's deflection in the deck. That's before the bridges. While the bridges just had the false work removed over in the building impound. And they say it's just expected, it's acceptable deflection. They don't talk about how much deflection it is. They don't measure it. It's not talked about. It's just, obviously, it's beyond what you can see with your eyeball. Because it's what you can see with your eyeball because somebody brings it up, but nobody brings up measurements. So it's deflecting so much so that you can mention it with just eyes. His local 10, I'm going to get you. But now the cameras are all absent, apparently, with all these people with these cameras, NTSB cameras. Now I can't find a single NTSB with a camera. So I guess the NTSB can come in here and ask Google to scrub the images with them holding cameras around their neck and everything. I don't find them. Let's go up to this image here. Let's see if we can get in the NTSB's website and see if we can find these cameras draped around their necks. I'm doing this live for you. But while I'm here, I want to show you this photograph. Oh, great. I guess I'm going to zoom in on you. I've been holding out on this one. I was hoping nobody in another forum would catch it. Right here. This is appears to be number, they call it north and south now, no longer A and B. So south would be the one out of the deck, I'm assuming, and north would be the one above and the top of the member here. This appears to be, because this can't be in two places, this appears to be the north post-tension bar. ripping through this, whatever the concrete is between north and south post tension bars. That's to be expected. When it fell down, it probably whipped it out and kicked it the other direction, which helped pull it out. All right. So let me, one more time. They have a video, B-roll, right? The B-roll shows them with cameras. And now, let's see if I can pause it and get that B-roll. And now we can't have these photographs, though. I'm going to send this to NTSB saying, hey, I know cameras are present. You guys are all absent some cameras. There looks like a camera on this guy's neck. Okay, hold on. Okay, so now we have the B-roll. And there's the date of the March 17th. This is the rubble, obviously. Cameras. Oh, let me back that up. There's NTSB taking photographs. They were all taking photographs, camera here, camera here. She points to it even. Why don't they present those photographs as part of their report? They find them non-useful. Well, we would find them pretty damn useful, I'm sure. This is the ripping of the piano keyed out post tension bar. Stirrups. Anyway, there's a camera, and you're going to see her next point to where she wants the photograph taken. Right there. So we got plenty of photography, cameras everywhere. But now all of a sudden we don't have those presented in our video. Here is numbers. They call this south now, no longer north and south. It's north and south, no longer as the plans would say A and B. I mean, why would you change the name of the damn plans if you're trying to talk about something relating to plans? It doesn't say north and south. It says A and B. You just triggered me. That's all. Let me get out of this one now. I just want to show you cameras do exist, videos do exist from the NTSB. They're not presenting them. This is the beginning of the failure. February 28, 2018. There's the emails back and forth. This is CEI department. Please refer to the pictures attached regarding some cracks seen on trust members span 1 after the removal of the formwork. So after they remove the formwork, these cracks are presented. We will monitor these cracks. We talked about that. And then there's the photograph showing them all, the cracks. This wrong location of cracks was presented, was corrected inside this. So I originally said NTSB, crazy, they put this up here. They don't even know where the cracks are, they're up here. NTSB presented, so for correction on that, they presented this to the public, to us. And they presented this as if they made up the drawing. They didn't give it. They did not say this drawing is from the CEI, and any errors in the drawing would be the CEI's errors. No, NTSB did this, so presented it in that format. So they're not above. They're not above their trickery. Their trickery with their stuff here. Jose, below, please find quote self-explanatory email from the engineer of record regarding the crack inspection report post false work removal. Sorry, my throat is killing me. So he's saying to Jose, Jose is a CEI, see? And this is from Figg, Manuel, something like that. Below, please write. And they're blocking out, the report is blocking out a person they don't want us to see. How can you be forthcoming if you're blocking out, you leave all these people in here, but this person we block out? Why is this person blocked out? Why are they hidden from us? I have it in another report. I can find it. But I find that very telling that they want to leave this person out of this report and email contacts. I don't care about, that it's in a report now. It's public. All these people stuff is public. No one seems to be doing anything nefarious or crazy, tracking him down or docking him. All right, doxing him. The deflection of span 1 after removal of the false works are within the expected deflections. That's Manuel from Figg, professional engineer. The deflection of span 1 after removal of the false works are within the expected deflections. Deflections with an S. Regarding MCM's photos above, we're talking about, we need a better description of the location and widths of the cracks in order to provide you with our evaluations. So they want more data on those cracks. So with respect to the photos. So regarding MCM's photos, we would need it. So MCM, they said we'll need more, but with the other ones, they said on the CEI's photographs, the deflections S is after the former is expected after the deflections S. In general, and then he does an in general answer. So in general, I'm just saying to you about cracks, not these cracks. In general, but then I am going to say these cracks. The cracks seem to be very small, and some of them appear to be shrinkage cracks. Let me know if you have further questions. This is how the professional engineer answers cracks from a photograph. He doesn't go to the job site and talk about them. He says this appears to be, these are not together. These are, his thumb is here, this is forward. There's a torque going on here already, a twisting action's going on. You see the shadow? That's a twisting action. Here we got the shadow coming this way. This is high and low. This is not in plane. In plane, we wouldn't have seen any shadow. We would just see a crack like this. There's a crack he's pointing at here. We don't see, where's the shadow coming at? So the sun's coming down this direction. So we don't see any shadow here. So they're in plane. This crack is in plane, but this crack is not in plane. So there's a twist already taking place. This is after the false work. And then here's the shadow out here. So that's going to be nothing for us to snatch you off of that. I need to see shadow by his hand too. It helps me determine that little trick I just did with photographs. So the shadow shows that. So the deflections are talked about. The deflections are already presented in this bridge after the false works. The movements of this bridge is already happening. I want to keep this video short for my man here. This is the beginning of the failure. They disrespected the deflections. They don't talk about it, but here's the thing about it. They talk about the deflections, the deflections of span 1 after the removal of the false work are within the expected deflections. They ask about deflection of the bridge, but they don't mention the depth, the width, the rotation, how it's deflecting. But there's multiple deflections. Part of this report up here, do you see the word deflection in here? Pictures attached regarding some cracks seen on the truss member 1. He doesn't say deflection here. We go above here in this NTSB. Where did the word deflections pop in as a response to the cracks? Right here. So if NTSB didn't, why is he talking about deflections if no one mentioned deflections first? Because he knows those cracks are from deflection, that the bridge deck is deflection. And this is Figg. So Figg knew the deck was deflecting. And that means, unless it was designed to deflect, which is the compression, everything's supposed to be in compression. If you got some deflection going on the lower deck, you got compression on the canopy. And compression on the canopy in any format, you have a top and bottom part of a member. So the canopy itself has a top and a bottom, right? The canopy. If I were to bend that downwards, I create compression at the top of that canopy, and on the underside of the canopy, I create tension. So the same thing with the whole system together. If you deflect it down, you're doing it on the deck, you're doing what I just said, and on the canopy, you're doing it. Certainly, you're changing the profile of all the verticals and uprights and the horizontals. They're all doing it. I'll show you that in one of my foam made up products again that I can't push down on it without destroying it. So deflection in this is not designed to move. They're not designed to move. Let me pause it. Okay, this just looks like contact information as I look up here. So that's my clarity mistake on that. It just looks like we already posted a video on that, so that's too late. Cat's out the bag. So you guys know about the, let me come back to this page too. The cracks we always talk about, they're right here, these cracks. This is photo 6. Now they've gotten much worse later when we see them really open up and start cracking. But this is after this is because of the deflection, as the Figg engineer states. At this point, they're at this size cracking. The Figg engineer 456, and I mentioned too that one of my previous videos that I said that they don't know what they're talking about as far as I just said it, NTSB put it in the wrong place. Turns out that NTSB didn't do it. It was the CEI, and he mentions that they are in the wrong place. The cracks that are shown on photos 4, 5, 6 appear to be in the reinforced concrete chamfer region of member 11. This is what he's saying. They should be up there at 11, not the one I just showed you. The elevation view locates these cracks on the downstation side of the diaphragm number 2. Puts it in the wrong place, right? It appears that the arrow that shows the general location of the cracks was misplaced in the elevation view. But nevertheless, these cracks develop at the boundary between the diagonal compression member and its reinforced concrete bottom chamfer. And this is what CEI, this is Figg's engineer says right here. It is anticipated that MCM will seal these cracks in accordance with FDOT standards because they're less than half an inch, they're whatever the standard is they're using there, that they can just address it in that format, that they're non-structural at that point. But they are indicators of what's going on with the bridge, that the deflection of the bridge caused those cracks. But they don't talk about why. They just say, look, just seal them up. This engineer doesn't state why they exist. And then the cracks develop at the boundary between the diagonal compression member and its reinforced concrete bottom chamfer. So unless they're telling us that they were able to make that member shrink when they put the compression on it, then it doesn't even make sense. That doesn't make sense at all. All right, so they're stating he just said seal it up with some damn caulk, some epoxies, whatever. And it goes on. Let me get past this again. Let me do this. This is the beginning of the end. This is the most important thing. Here it is again. Dated February 28th. This is CEI right here. CEI wrote this. Please refer to the pictures attached regarding some cracks seen on the truss members of span 1 after removal of the formwork. Again, the formwork was holding the structure together. When they post-tensioned it, it looked great. And everything, they were happy until they started removing the formwork, and then all of a sudden the bridge just dropped down, as I stated. That's the beginning of the end. The bridge was already in its progressive collapse mode. It was headed out the door, whether they post-tension or detention number 11 and number 2, in my opinion, no matter what. It was headed out the door. For clarity, here's photo number 4. Now you see that's much more open. Number 5 and number 6 is what they're really concerned about. Number 5 is not part of the chamfer. Number 5 is in the member itself. That is what they call the south post-tensioning bar, probably in line with that one there. This is the reinforcement coming up this way from the deck, and into here is what the engineer from Figg stated. But it didn't mean it. He didn't say it caused it. He just stated that that's where it is. We already know where it is. And then he just stated caulk it, or, the MCM will deal with it later. But the thing is, why did it happen? And let's jump over to Louis Berger. I don't know if it has still been found anyway. Louis Berger was appears not to have been certified to work on this concrete structure as is to be able to certify its ability to work. He had not, they changed company names or hands or whatever, but nevertheless they lost their certification to work with such a concrete structure. Are no longer with the firm. With regard to work type 421, 4.2.1, previously qualifications are no longer with the firm. Qualifiers are no longer with the firm. To keep it as simple as possible for now, I admit seeking this work type, and I will submit new qualifications when you have the settlement. So that's Louis Berger stating they're not qualified any longer. stating that on December 28th, 2016. Now, I don't know exactly when they did it, but it appears that this is presented to us showing that they're no longer qualified to be doing evaluations. Makes you wonder if they went back to him to talk to him about this, NTSB, that they shouldn't be able to talk to him about it because they're not qualified to talk to about it. If they were qualified at one time, these people no longer work there. And remember, the one guy said he's no longer working for them in the firm. He says qualifiers, S. Remember the one guy we saw, and he says, I went my different way. Maybe that was the guy that was qualified at the time. Somebody else took over the drawings, and maybe that was wrong to do. I'm just throwing that out there. I don't know that to be true, but it seems like that puts that part of the puzzle partly together. You know, three sides of that ship. I don't know if the fourth side is going to fit. So this 2-page with the NTSB questioning. Is Louis Berger currently still not qualified for FDOT to perform the bridge type 421 design? Answer, that is correct. Louis Berger is currently not qualified with FDOT to perform the bridge type 4.21 inspections. Provide a listing of the bridge work that Louis is currently qualified for. And they asked that. Oh, I'm sorry. Answer, 4.1.1 miscellaneous structures, minor bridge design, 4.22 major bridge design steel, not concrete. And the firm Louis Berger is no longer qualified with FDOT. Qualifications for the Louis Berger Group Incorporated expired on 12/30/16. The Louis Berger Group Incorporated qualifications expired due to transfer of staff to their affiliate entity, Louis Berger US Inc. From Louis Berger US firm, Louis Inc. is currently qualified with FDOT. Is currently qualified as of 1/17/17 and other work types, but not major bridge design. All right, so you see what happened there? That guy took a bounce, and that there went the qualifications, I think. All right, I'm trying my best to keep it under 30 minutes. I'm at 27:28. 16 pages from the Turner Fairbanks. That's the government's concrete research. What I want to point out in this one is they're going to stay clear of the cracks on the other side of the structure. They're showing this side. They're not showing my greatest cracks that I keep coming back to. They're not showing these cracks. So this is Turner Fairbanks trying to show a nefarious. It's nefarious because they're not going to show the other side, but they're going to do these. They left the banner on here in this photograph, and they could have used something else. Let's move on. I'm going to show you that just scrolling up here that they're going to talk about all these cracks and everything else, and to fit their failure mode. Chamfer at south end member 11 connection to the deck. This is that deflection in the deck. This is more further proof deflection is happening in the deck. This is taking place on, what date we got here? Sorry about that. It looks like I'm going to cross 30 minutes by a touch, right? September 23rd. Yeah, they just need to put this up here. All right, so we got the deflection in the deck causing this separation here. This is not, let's see if I can get a better timeline of that. See what they do here? They don't even give us the exact timeline. Apparent cold joint. Or yeah, whatever. But that's not a cold joint. That opened up. That's that bottom of 11. That deck is going down, creating a hinging effect also on the joint, this opening of this. When the deck is deflecting down, that has that negative moment going on with the back of this deck, and also the interactions with number 11 and 11, that triangle I talk about, prying it open, prying it up like that. Interface after collapse. All right, so this is just smoke and mirror crap again, because this Turner Fairbanks also now micro managing small details with an arrow inside here. But apparently they can't micromanage this huge detail. I'm going to move this over. Right here to the right. They can't micromanage that, but they can say, aha, look, there was a bug right here, and this bug caused a fissure. they caused a shape like a wedge bug, and it wedged it, and whatever. I'm just talking trash at that point, but you get my point. These we didn't find these initially. Now we find these in this present. This is interesting, lying bent over like this. These are the photographs we would need to look at. It looks like they just swept up their rubble left and right. I already talked about this cover, this material that they placed over it in many videos, saying it looks like they covered the structure, top, bottom, the deck, everything. Not the bottom, the underside of the canopy. I showed how it was white, and people talked about the whitewash on it. Well, so they act like it's a big deal now. This photograph here, they talk about a couple times where it was where the this is very important to me, failed rebar, where they talk about this sliding action going on. It sheared off this number 11, this where it stayed here, this dotted lines, pushed off this 12. How can it do that with this in the way? This is in the way. It's still there. Does this look like it's been pushed off? Look at the back side of this. As number 11 is doing all this pushing, does this look like it's crumbled and crushed and deformed? But then they point to these two and say, it did this. The one is pushing it off. That, to me, I would tell you that's a pop, P-O-P. It popped off as it was hinging off, that this elongated. They could measure this and tell that if it necked, it got smaller at one end or the other, necking. They could tell that, and that would show the popping. Shearing going that way, it looks like a uniform circle pretty much around the location here. It looks like a pop to me. A failure through popping out, not through sliding off this direction. The sliding thing is just a hoax. It's just BS. I call BS when I see it. I just call it. It's triggered me, guys. It really triggered me. That this cracked up member here with no structural stability, just looks like a piece of junk. This number 11 can now do all of that. I just say that, that Linda Figg, Denny paid whoever they are, whoever did the lobbying, Figg Engineering, they got what they paid for. They really got a report that's junk. It helped them out. Here's the sliding action that's supposed to go on that sheared so perfectly that it sheared this, and it didn't even deflect this. It deflected up here, guys. See the moment? It's up here is what is going on at that point. But down here we got no bending moment, no shearing action, no partial necking, no compression. But it went around this, got to this rebar here, and sheared it off. This thing over here to the right, this crumbling up defective member went over there, and then it went around. It ran around that. This is a popping. This is popped. It's popping. I know it's not pushing down and creating this initially, because it wouldn't do it. The crack would look different, and you wouldn't get a break in it. You just compress steel. That steel is going to love that compression. Is where it's going to shear. It's not going to do anything. And pushing down, you're not going to break it. You're compressing it. You're making a mushroom. There is no mushroom here. This is perfectly even. This shear, you couldn't even create it with this shear action. You'd have to use a chisel, and you still couldn't get it to create the rest of this because it's so flat. You'd use a chisel to come across it. To me, this was an elongation. It popped, failed right there, and then the rebound is what we're looking at when it released the load. This is that rebound, rubber band effect, if you will, pulling back in, and that's that crack. The rest of this crack recessed below this because it's avoided under there. The loads were so great. But under here, if you would take this apart to prove that, you'd go to the other side of it, and you would just dissect this, grind it off, dissecting gently without ever touching this, and measure it. Look for the necking. You can measure the surface, too, and see if it's per manufacturer's specs, if you see necking on the top. It's BS. Their version, they're not counting on anybody like me challenging them. Obviously, no other engineers out there have the balls to challenge them. They're just falling in line, lockstep. And that's the problem with engineering. They lack logic. Now they talk about apparent cold joint. I think this is beautiful. Look at this roughing that's saying that didn't exist. Turner Fanbanks and all of them saying that MCM didn't have roughing. I cried about MCM appeared to polish the concrete after that. It turns out that was because they were supposed to roughen, and maybe they were doing some prep work. But nevertheless, MCM looks like they roughened that. I mean, come on, is that smooth to you? MCM's argument is weird as hell, though. They don't present their argument to this, they don't argue. They sort of throw in the towel and move on. Interesting enough, they throw themselves under the bus, allow themselves to be thrown under the bus. Figg did a long report on this. We saw a counter. But MCM doesn't argue back besides some stupid photographs they presented, which was just nothing. Again, this is the roughened surface. This is the core sample. This means they took that round drill bit, and round drill core, and they went down here. And these striations you see is the source rotating around. Vroom, vroom, vroom. These are just lines, just like you're using a lathe machine. There's the air pockets, the voids, the stones, the aggregates, whatever. This is that cover that's on top of there. It looks roughened. Clearly, it didn't slide off because this is part of the core. So you can't say it slipped. It didn't slip here. And they say this is at the back of, and I saw the photograph of it, this is at the back of 11 where it's supposed to be doing the sliding. Well, I don't see it sliding. Wake up. Okay, I'm going to terminate that part. And I'm at 36 minutes. Shucks. Now, I might end the video with this. This is Structures Technology. The construction manager, superintendent, did a good comment here. Saturday, we brought in the crew from our out of town, the detention of the bars per your request. Saturday was when they moved the bridge. The cracking was observed. The cracking was observed on the bridge. However, prior to additional work on the bridge, the engineer record needs to analyze the bridge before any additional work is done. So this is the crack, and then after the cracking, this is the day of the move. After the cracking, they're trying to get them to come back to retention. But the superintendent argues back for us to just bring guys to this site Thursday will delay delay other projects. Please check with the engineer of record if work is to be completed prior to the stressing, such as epoxy injection to fill any voids and avoid further cracking. He wanted the cracks to be made stable before he started putting 560,000 pounds of force in this area. In other words, if you got the loose gaps and all that, and you start putting 560,000 pounds of force, it's going to move. It's going to close those gaps. It's going to close it. It's going to change the shape of it. But the gaps, when I say close it, it's going to close the gap in the bar itself. And if that concrete doesn't come along, well, then it breaks around it. So it comes with it, or it doesn't. It's going to close the gap in this. It's going to try to get the 560,000 pounds of force. And if it never gets to it, well, then it never gets to it. In other words, it could just keep ripping right on through because it never meets the total 280 per bar. But after the engineer record reviews the area, we can schedule the appropriate crew, whether being epoxy injection crew first or the stressing crew. So we know now that this report, VSL is stating, it appears to be VSL, Structures Technologies, using VSL, I guess, so equipment. So Structures is stating that the superintendent is clearly addressing that, look, we're the post-tensioners. We'll post-tension, but we need this addressed by the engineer. And should we bring our epoxy injection crew or the stressing crew? Oddly, though, he shouldn't say the stressing crew, because I think he should say, well, no, we're not going to stress it with gaps in it, even if the engineer says that we can do it, because we don't stress gaps. We're not, we don't do that. I guess he would do it for the right money, but it's just weird. It's just, well, he's not an engineer, so he wouldn't see the issue with that, the major issue with that. But nevertheless, there's VSL stating that, hey, we need these cracks fixed first, and then we can stress. But that was not the way it happened, was it? So remember, the bridge was stable at that time. When I say stable enough to clear the road and everything else and figure out what to do. Before post-tensioning happened, it was stable enough that no one could get hurt at that point, could get hurt, as long as you're not doing anything. But since the engineer said go ahead and now stress it, he caused the failure of that triangle, I call it, the 12, the canopy, and number 11. And of course, the joint is all part of these are a part of it. He caused the failure to accelerated failure of the entire triangle. So let's throw Dwight Dempsey under the bus, because he's a professional engineer, structural engineer also. This is his how to proceed, sent via mobile. device. As you and I just discussed, please find the additional recommendations and requests below that Figg thinks will be beneficial for the structure. Again, we have evaluated this further and confirmed that this is not a safety issue. This is Dwight Dempsey stating this, not a safety issue. I don't see where Figg states that besides in the voicemail, but he could be stating that because he's representing Figg Engineering and Dwight Dempsey, structural engineer, states such. So now we got to let Figg get a pass on it's not a safety issue. It is recommended to, because he's quoting his own engineer, it is recommended to reinstall the 2 3/8-inch temporary post-tension bars in truss members 11. I find this interesting. He says reinstall, like they were totally removed. As shown in Plan B 38, these, and he's going to say grout, I believe too, these are oriented with one bar at top of the bar. Okay. The temporary post-tension bars in truss members 2 do not need to be reinstalled or restressed. The temporary post-tension bars in truss members 2 do not need to be reinstalled or restressed. He did not. We've got reports that said they did number 2 and they were moving on to number 11 at the time. Dempsey states that don't mess with number 2. Leave it alone. So this is kind of contrary, conflicting stuff everywhere here, but I'm going with this. Both post-tension bars should be stressed to, this is on number 11 now, 280 kip stressing as listed on Plan B69-69. And these bars shall be stressed in 50 kips increments, then bottom post-tension bar, then bottom, so he's showing how to do it. The Type 2 diaphragm shall be closely monitored during this post-tension stressing process to ensure that crack size does not increase. So Dempsey stating that you can post-tension it, but crack size must not increase. So if it increases at all, so must. So you know, guys, I don't throw the baby out with the bathwater. So I may be attacking Dempsey, but I also, am fair. The crack size does not increase. So it doesn't. It's not an option to say does not increase. Is not an option to say it increased by 1/16 of an inch. That's not an option. He says it does not increase. 1/16 of an inch is an increase. If VSL doesn't understand what they're contracting when they read this, then they should have just stopped and they're not qualified. They should say, wait a minute, we can't guarantee that. What is your definition of increase? 1/16, 1/32? We need a scale here. What's an increase? And if they say anything, we'll go, we can't do it because there's going to be some change. So if it's going to be some change and there's going to be some increase somewhere when you start to tension and detension and then tension again, because the nut has to be tensioned first, which you're going to put more compression in the joint to loosen it to back it out. So that creates a new moment of increasing at that point. So you just have to say this doesn't make sense. Based on our evaluation, we anticipate that the crack size would either remain the same or would probably decrease in size. So this is Dempsey saying R2. He's got a mouse in his pocket. Somebody else he's talking to. If the crack size increases, the post-tension bar stressing shall. This is not an option. Shall stop, and Figg will be notified immediately. So any increasing shall stop the work. We understand the MCM was to contact VSL to see when the... Okay, go on. We request to receive the concrete break reports from the lab, right? That's the testing. We understand the MCM is currently placing the shims under the Type 2. We saw the shims are there. All right. So, you guys, you see, there's more data for you. So, guys, I want you to know the change. Truss members 2 and 11 de-stressed. Nuts to be left placed hand-tied and ducts to be grouted. They intended that to be grouted. So, even though it didn't show somewhere else, there was a change somewhere that this was intended to be grouted, those ducts. And here we are, further indication that the triangle, the number 11, 12, and canopy are now allowing this torque action to take place. This is after detensioning. The deck deflection now can show itself in this capacity, which is huge. It's getting much larger here. We're well over, from here to here, we're well over 1 inch of failure. From here to here, 1 inch gap. This is really opening up. And up here too, we got a torque action going on where the rotation is happening on top of this. And this guy is standing here, and they're claiming that this deck is going to slide this off. Yet it's totally loose right now. No sliding is taking place. No sliding is taking place. A hinge action is taking place. This is dropping down also, the deck. And this color is not my fault. This is like a really dark shade this way. It's in the report this way. So I apologize if you guys think it looks a little darker. So as I zoom out, this is what they're stating is pushing off 12 now. This crack, an open crack, all the way down to here, has a compressive moment against here. I call it an air gap pressure that these engineers, FDOT, NTSB, all of them use an air gap pressure. I play around with a lot of things, and this would be one of my favorite ones to play around with trolling, is that, and it's trolling myself, that this is pushing here. It's an air gap between it. It might as well be 30 inches. A gap is a gap. One is not going to push the other unless you've got some type of confined compartment where air is not compressible. Air is compressible, so you couldn't even do this. This is just craziness to say 11 is pushing off 12 at this point. This is separating from each other. This is not an action of compression. Now you would arguing that, well, not when they start compressing this, then it pushes it off. Well, right now, evaluating this crack, there's no comments about this crack by NTSB. The entire report, there's no comments about what exactly is going on with this crack at this stage of the game. That's what I'm ending the video with, that they don't talk about each stage of the game. They just allude, jump around everywhere to just avoid the deflection issue. The number one thing is the deflection issue with this structure. Here it is, page 64. The number one thing is the deflection issue. Look at this thing opening up. Just failing, coming apart. The deck is deflecting underneath his knee in a downward motion, and this is what is exhibiting himself because it's no longer has the clamp force of what they call north and south, A and B. Clamp force to help maintain this. This has a natural torque action, a twisting action, as shown in the previous video I showed. And, I mean, that's it. I mean, this is not pushing anything off. This is totally junk. They say this is it was going to slide off everything out. What does it have? Where does it have the ability to slide? What broken arm and broken leg could slide that off? This is just failed all the way down and is twisted and torqued. Oh, I'm so triggered. Further indication of that twisting action of that number 11. Here's the spalling, popping of the concrete. There's the crack, greater than 1 inch. There's the cracks on the other side, greater than 5/8 of an inch. He's sticking his rule down there. There's this concrete before it spalled off in the previous image, a couple images back, before it spalled off. Here them sticking the tape measure down that huge crack all the way down there, showing the voids inside, the internal voidage. 7 voidage, that's my word, 7 inches at least. This is crazy. Here are the longitudinal cracks down this entire deck. Now this deck has transverse cabling across it, and yet this crack was able to develop all the way down as far as I can see. So the transverse cabling, post-tensioning cable, apparently couldn't keep this thing, it's under load, that's for sure. Looks like it's going to butterfly apart, doesn't it? Right down the center of the deck, of all things. Yeah, this is what I said I would hope to find, remember, at one point? Really? Goes apart, across the drain, but they don't show it. It appears to go across the drain. Okay, so this appears on 3:10 at 3:16 p.m. Another construction. So it appears cracks are present. Look at that, right behind there after the move. Or is this after detention at 3:16? They stopped at 4 o'clock? I don't know, but nevertheless, they're not very clear about that, whether it's before or after tensioning. But there are the cracks behind this banner. Okay, never mind. I can update that because this is 3:09 p.m. He said person working on the canopy with crane hovering. Okay, maybe they were detensioning. And here's 3:09, and at 3:16, 5 minutes later, we have this photograph. This person's there. The STMTs are removed. The road's still closed. You still got these guys out here. So this thing was yeah. That's not a post-tensioning crew up there, is it? They're not detensioning. It's only a single guy here and a single here. So uh, okay, page 41 of 84, bridge factors photographs 1 through 111, if you want to find it. Doesn't that look roughened to you? I don't know about you guys, but that shit looks really roughened. So what's this about MCM not roughening or it's not presented? Um, wow, I'm just, and this might be the cover at this point. That's shabby like that because it does have a laminate on it, but nevertheless, I'm just bringing that to your attention. And here's the beginning of the end. This is the deflection again. 226. Well, still in the casting yard. There's the deflection in the deck. Remember, the post-tensioning is still present. So if the post-tensioning is still present, we can say that this has got nothing to do with post-detensioning or retensioning, because this is why it's still in the casting yard. Formwork has been removed, and this presented itself. At that point, deflection is noted, discussed, and these cracks are discussed as a result of the deflection. So you don't have to tie this into anything beyond that at this point. Just in the casting yard only right now. You don't have to look for shims underneath of the end diaphragms or anything else that might cause this. Nope. This is just removing the formwork in the casting yard, deflection, and we have this presented. This alone, one is related to the other now. There's nothing downstream that you have to talk about here. Nothing downstream. And now we see that the joint here looks kind of crappy, but we don't have this. You can't talk about, well, this is the clamp force creating a sliding action, and this is how you get a pair of scissors under there. Nope, this is before that even happened. This is, again, the casting yard. So here's the data before the casting yard. I got to end the video. Sorry, I took double time. I can't add more to it. I can, but I got to stop. Take care. I'll do more videos.